Hello, calculus students. All right, here are 6 more examples if you need them for how to take the derivative of functions using the chain rule. So, first as a review for the chain rule, if you have the derivative of f of g of x, there's a function inside the function, you take f prime, you leave the inside alone, then you multiply by the derivative of what's on the inside, g prime of x. So on this one right here, let's start off with identifying what's the outside function, what's the inside function. Well, it often helps to think about like where the parentheses. That whatever's the inside function is what's in the parentheses. That's the g of x. The outside function here is the square root. So I'm going to rewrite this actually. X squared plus 2x plus 7 to the 1/2. Because this allows me to use the power rule. So now I'm going to find the derivative of this. So to find the derivative of anything to the 1/2, I bring the exponent down, 1/2, and then I take the exponent, subtract 1 from it. So 1/2 minus 1 would be negative 1/2. Then I got to take the derivative of the, I'm going to leave the inside here for now, x squared plus 2x plus 7. We'll leave the inside here alone for now and for always because I'm not going to change it. But I do have to multiply by the derivative of the inside. The derivative of the inside is going to be, well, what's the derivative of x squared? Well, that's just 2x. What's the derivative of 2x? Well, that's just 2. Now, please be careful. Make sure you put this in parentheses because we're multiplying 2x plus 2 times times this whole thing, not just times 2x. So be careful with that. But that is my answer. Could I simplify this? Absolutely. If it makes you happy, we can do that. So negative 1/2 means the square root would be on the bottom. Square root of x squared plus 2x plus 7. I'd have on top 2x plus 2 because I'm multiplying. On the bottom, well, it's 1/2, so I'm going to put the 2 down here. And if you want to simplify further, we can factor a 2 out of all this at the top and get x plus 1 over the square root of x squared plus 2x plus 7. And that's your answer. Can you leave it right here? Absolutely. Woohoo! Can you simplify it? Sure. Both are acceptable. All right, next one. I'm going to rewrite this again. I'm going to rewrite this negative 2 times 4x plus 1 to the negative third. Because now I can use the power rule on it. So let's see here. F prime of x. So for the power rule, I got to bring this down. So it's going to be negative 2 times negative 3. I leave the inside alone. Inside is still going to be 4x plus 1. Subtract 1 from the exponent, so negative 3 becomes negative 4. Then I have to multiply by the derivative of the inside. Whoop. So derivative of 4, x plus 1 is just 4. And that's a perfectly acceptable answer. That is correct. If we want to clean it up and simplify, you can if it makes you happy. So that's going to be positive 6 times 4 is going to be 24. Negative exponent means this is going to go on the bottom. 4x plus 1 to the 4th. Both of these are correct, though. Both of these are correct. All right, moving down to this one. This one is super sneaky. Super sneaky. It's a sneaky monkey, as Mr. Hanky would say. I'm going to rewrite this. F of x is equal to cosine 5x minus 3. Cosine cubed really means this. We do that because if I just put the 3 up here, it looks like I'm cubing 5x minus 3. So we're going to write it like this instead. And now what we actually see is we've got a function inside a function inside a function. My outside function here, the outside function of this is something cubed. My inside function is cosine, and then there's a function inside that, and that's 5x minus 3. Well, let's just do one at a time here. So the outside function is going to be 3. The outside function will be 3 something squared. The derivative of my inside function here is going to be, the cosine is negative sine, but there's a function in there too, and I got the, what's the function inside there? Well, the function, derivative of the function inside there, derivative of 5x minus 3 is 5. So I still have to come back here, leave all this other stuff. Cosine of 5x minus 3, that was all squared. I'm multiplying, make sure I drop my multiplication symbol there, that's very important. Multiplying times the negative sine of 5x minus 3. Again, what's inside stays inside. Then I multiply by the derivative of that inside, and I get this. So derivative of this was there. The derivative of this is right there. And that's the answer. If you want to, you can put parentheses around this. But f prime of x is going to be 3 cosine of 5x minus 3 squared. Let's see here. I've got negative sine of 5x minus 3 times derivative of that, which was 5. And could you clean it up? Sure, if you want to. We could bring the negative and the 5 out front here and make it negative 15. Cosine squared of 5x minus 3, sine of 5x minus 3. But this is perfectly acceptable. All right, on this one, now we're starting to get a little bit tougher because not only is there a function inside my function, but I've also got, I'm taking it times another function. This is a product rule and a chain rule in the same problem. All right, so let's do the, first I'm going to rewrite this. F of x is equal to 4x squared times 9. Don't you run it out of me? 9. Times 9 minus x squared to the 1/2. Okay, so you may be asking yourself, Mr. Kuhn, when do I do the chain rule? Do I do it first? Well, don't have to do it first. No, because right now I'm just going to start deriving this. I've got to take the derivative of this function right now. So f prime of x, derivative of the first, derivative of 4x squared would be 8x. I leave the second function alone. 9 minus x squared all to the 1/2 times, plus, why didn't I take the derivative there? Why didn't I do the chain rule? Because I haven't derived this yet. I derived this, there was no chain rule necessary. I wasn't deriving this, so I don't have to do anything yet. Now we're going to add, well, let's see here. 4x squared, the derivative of this function now. So what's the derivative of 9 minus x squared all to the 1/2? Well, the outside function is the whatever to the 1/2. So I'm going to bring the exponent down. Subtract 1 from the exponent. I leave the inside for now, 9 minus x squared. And then I'm going to multiply by the derivative of the inside. Now's the chain. Derivative of 9 minus x squared is, derivative of 9 is nothing, derivative of x squared is 2x, so this will be times negative 2x. Now, can we clean this up? Sure we can, if you really want to. We could say this is 8x times 9 minus x squared to the 1/2. Now, those 2's cancel out. I've got a negative now, so it's actually going to be minus 4 x squared times x is x cubed. The square root's going to be on the bottom now because it's negative. And that is a perfectly valid answer. So is that one, though. All right, moving on to number 5. Tickle my throat. So, I've got a function in my function. Do I do the chain rule right away, Mr. Kuhn? No, we don't. First, we're going to take the derivative of tangent. F prime of x. Derivative of tangent is secant squared. I'm going to leave the inside alone. X over 8x plus 7. Now, I got to take the derivative of the inside. The derivative of the inside means I have to derive this problem right here. Oh, man. That's a quotient rule. Yep, it sure is. So that means we got to use our quotient rule formula. Low-de high, high-de low, all over low, low. So low, 8x plus 7, d high. So what's the derivative of x? Well, that's just 1. Minus high, x, derivative of the bottom part, derivative of 8x plus 7, well, that's just 8. All over the bottom squared. Low, low. There we go. Now, and I'm going to put this in here just to make sure that we know that we are multiplying this times this. And no, I'm not going to simplify that. I'm going to leave it just like that. And the last one. Oh, man, another quotient rule. They must love us. So, nothing to simplify here, actually, or nothing to rewrite. F prime of x. So low, sine of 6x, d high. So what's the derivative of x to the 4th plus 2x? That's going to be 4x cubed plus 2. Make sure you got parentheses around it. Low, d high, minus high, x to the 4th plus 2x. Put that in parentheses. D low. So now I got to derive sine of x. Derivative of sine of x is cosine of, oh, Mr. Kuhn, it's not sine of x, sine of 6x. That's all right. Sine of 6x. There's a function in this function. I derived cosine. Derived sine, got cosine. But there's a 6x inside it, so I got to take the derivative of 6x, and I get 6. So that's where the chain came in, right there. So low, d high, minus high, d low, all over low, low. Sine of 6x squared. And no, I'm not going to simplify that. I'm going to leave it just like that. So there you go. More examples of doing the chain rule. Woohoo! Some of these we had to use the product rule and the quotient rule along with it. You'll also notice that a lot of these, it's easier if you rewrite it in exponent form so that you can use the power rule on it. Thanks for watching.